So just like a little bit about myself that makes me really happy to be here. My family's originally Italian. I grew up in Argentina. I speak English, Spanish, and really terrible Italian. But it's really cool for me just from my heritage to be here. And like, I'm sure my great grandfather would have never thought I'd be presenting at a Python conference in Italy. So I'm going to talk to you today about modern observability for Python. The idea is that we're going to start a little bit with a history of observability and end up like at where we are now. My goal is for everyone to walk out of here having like a general idea of what the observability landscape looks like, no matter where you are in it. And so yeah, let's get started. So where do we start with? Sorry, let's go this way. Our agenda. So like I said, a little bit of history. I'm going to talk a little bit about metrics and traces, which is kind of more the newer observability stuff. We're going to talk quickly about distributed tracing and end on OpenTelemetry, which is the newest, best thing in observability. I think the history is important, because especially in this situation, because the history over the decades actually mirrors a lot what you end up seeing in projects. You start with something simple and then you start building up to something more complicated. And if we just look at, if someone just throws at you the more complicated thing without understanding like where it comes from or why you'd want that, it can be a little bit overwhelming. So yeah, history. Let's start with print. Print is the king. Print has been around forever. I still use print. I'm sure everyone still uses print, all the time. It just works, and it's simple, and it's always there, and it gets the job done for a lot of situations. Print has a lot of different forms, and in particular, like ways to format the strings. You have the like the sprintf style formatting, which is has also been around forever. It comes from C. It's a little bit kind of gross. You have the dot format style formatting, which now you start getting a little bit nicer. You can like name your things. There's like, you can use format specifiers easier. And there's f strings, which is kind of the newest thing that you'd use. So even within print, there's like evolutions, and I pretty much always use the f string style format nowadays. But yeah, it's the brief history of print. It is the king. And then you have logging. The standard library logging. It's been available also not forever, but since Python 2.3, so quite a while. It can be a little bit gross. There's parts of it that are like designed around how it works in Java. So there's like camel case names that already is like a turnoff for a lot of people. It's quite complex to actually get working. Like I remember struggling to get it working to start with, which is not the usual experience with Python. But there's all this kind of stuff going on, right? You have like the loggers, the formatters, the handlers, like all this kind of stuff. This diagram's showing a little bit how that flow goes. Usually you'd call like logger.warning, logger.info. There's a lot of this that is related to early termination because logging can be expensive. So if you're, for example, emitting debug logs, you don't want to do a bunch of work only to decide to drop those on the floor. So there's a lot of work that goes into just like, if your level's less than warning, then immediately drop it. If a filter says to drop it, then drop it. And only if it passes all of these checks does it actually end up getting emitted. So yeah, the flow is kind of logger.info, logger.warning. Then you can have filters on the logger itself. If those all pass, then it goes to the handler, which can also have its own filters. Then it goes to a formatter. Now it's a string, and then it gets emitted somewhere. A couple of interesting things is that this is all built around like, it ends up being a string. That's the idea. It's going to end up being a string somewhere, which, as we'll see later, isn't really what you want nowadays. You don't really want string. You're not just like putting something on a terminal and it ends up in a text file somewhere, and that's like all you can do. There's also this whole other part that's not even here about like logging hierarchies. If your logger has a dot name in it, then it starts interacting with imports kind of in a weird way, and that's also probably not really what you want to do nowadays. This is what it looks like to set up standard library logging. This kind of simplest form possible. I have a formatter that's using kind of these sprintf style strings. It's a different, slightly different, but the point is I'm going to put it like a time in there, the level names like info, error, warning, and my message. I'm using a stream handler, which means it's just going to go out to like the console, pretty much the same as if it were print. You can do all kinds of other stuff. You can write your own handler. It can send things over HTTP. It can write them to a file. Those are, I think, the two most common ones would be you send it somewhere remote or you write it to a file. Then you have to make sure you configure the root logger, which you refer to with an empty string. Totally makes sense. Make sure you give it a level. I forget to do this all the time. Otherwise, you'll configure the whole thing, and there's no level, and then the default's warning, I think. So when you try logging.info, it's just not going to come out, and you're confused as to why. And then finally, you'd call a function like this, and then run the rest of your code is basically the idea. This is what it would look like then to use standard library logging. So that would be like in your main function, in your entry point, where you set up your application, something like that. And then this is like if, in one of your modules in your application where you're just trying to emit some information. That part's a bit easier. There's, it's slightly confusing with a dunder name thing. I'd say just don't think about it. Just always use dunder name. That's going to be the name of the module. Make that the name of the logger and call it a day. You can get a little bit fancier, especially if you're like a library and this is inside a private module and you don't want your logger to be called some weird private module thing. Then you can just pass in a string that's dot formatted the name of, some conceptual namespace of what you're trying to make it. So it could be if you're an HTTP library, it could be HTTP dot, send or HTTP dot receive or something like that. But yeah, configure a name, make a logger instance, which can be a little bit confusing. Why need to make a logger instance? It's just to give it a name. That's all. And then you can use that logger instance to emit logs. So there's pros to standard library logging, and the biggest one really is that it's built in. It's there. It's part of the language. You don't have to add any dependencies. It's always available since Python 2.3, so any version of Python that you want right now. It's worked the same for a while. It's super reliable. The cons are that, as you saw, there's complex APIs. There's all these loggers, formatters, handlers, all this kind of stuff, filters, all this kind of stuff. There's lots of choices. You saw the configuration. You have to configure everything. You have to choose what type of format string you're going to use up front. There's no structure because, like we said, it always ends up as strings. You can kind of hack this a little bit. You can build formatters that take your data and JSON dump it, and so now you're emitting a JSON string. So you're kind of serializing it still to a string, but it's now parsable in some easier way. But also they have no context. Logs have no context. Aside from the name that we set, the module name, you don't know where they came from. You don't know if you see a bunch of logs, pretty much that one happened after the other one for the most part. But you don't really have much more information on what called what. Is this the same request that's being processed or two concurrent requests or anything like that. So enter tracing metrics. These are relatively newer things that have shown up in at big companies over a decade, but realistically for most of us developers the last decade. Context matters. Like we just said, logs have no context, and one of the really big things that traces bring to the table is context. So you've all probably seen a stack trace from having some sort of error, like the thing on the left, right? I have some function called foo, which calls a function called bar, which calls a function called baz, which then divides by 0 and has an error. But I can see what called what. And that's really, really valuable information for debugging that logs don't have, but traces do have. So you can think of traces as kind of logs with context. So if I have, this kind of pseudocode here where I'm emitting what I'm calling spans, that's the nomenclature for a unit, a block of code or execution in tracing. So I'll make a span within foo called doing work emoji, and then call baz, and then within baz I'll start another span and then do my divide by 0. So if I run this and I get that error, and that's in my logs, I'll have not just the final stack trace from the error, but also each one of these will know which called which. So I can see the whole sequence of calling. Duration also matters. Logs don't really have a duration. Like logs have a timestamp, and you can kind of measure the duration of your code and then put that into your log, as kind of text somewhere. But they don't really natively have an idea of duration. Tracing and spans do. So every span, you'll see their context managers. It's essentially measuring how long the code within it takes to execute. So if I have this doing work span and then I sleep for a second, and then I call Baz and then I sleep for 2 seconds, I'll be able to tell from my traces that it's not that Baz took 3 seconds, because I have another span around Baz. I can tell that Baz took no time at all. So I'll know that there's something slow going on within foo. And then I can go look at my source code and see there's a couple sleeps in there. So I want to be practical here. I think it can be confusing to see all these different things, and I want to give you some practical advice on like when you should use tracing versus logging versus blah blah. Pretty much, I'd say use tracing. It's going to be the bread and butter of your observability. Whenever you can, put tracing information in there. It carries a lot of information. It's really useful in a lot of different contexts, debugging errors, debugging performance. And there's a few cases where you'd still want to use logs, like things that just don't have a duration, it doesn't really make sense to have a duration. You can still use logs, but for the most part, you're going to be using tracing. Now let's talk about metrics. Metrics are something that kind of showed up before tracing, but I think a lot of people still don't use. They're this kind of thing that like, big companies would use, and you have to have like huge teams to manage them. Nowadays it's a lot easier. But really where the power of metrics comes in is in summarizing large amounts of data. So say you have a service that's doing a lot of requests, right? And you start putting these trace things in there for each HTTP request. All of a sudden you're emitting, a duration, essentially like some lineage information of who called who, and all that kind of, maybe some structured attributes that you're putting in there, like some headers, the username, like for every single HTTP request. That can get expensive. So you can use, stuff like sampling, which we'll talk about later. But really, you probably still want to measure the latency of your server, so you can start emitting metrics for that kind of thing. And that means you're just measuring for each request, like how long it takes as a number. And importantly, you can aggregate that really performantly. So your application will do statistics on that and emit like distribution of latencies before it even sends it over the wire. That's very compact to send. That distribution of latencies can then go to a collector or to some sink, which then takes that and reaggregates it for all of the instances of your service. If you have multiple deployments on multiple EC2 instances or Kubernetes or whatever you have, you can reaggregate that. So and then what you get is that aggregated number that's super cheap to store, super cheap to do operations on, and you can make these sort of pretty charts out of without costing you an arm and a leg, both in terms of amount of data you're sending over the wire, amount of data you're storing. So when should you use metrics? Metrics are great when you're trying to get accurate summary information that you don't really want to sample, but you also don't need the full traces for. And finally, when should you use logging? I think logging is mostly superseded by tracing. There's not that many scenarios you'd want to use logging. Like I said, there's if you have something that doesn't have a natural duration, but really a lot of it is integration with existing code bases. You might have a code base with a lot of logging and you want to integrate that into your tracing, you can do that. You might have third-party libraries that aren't really instrumented for tracing and are only instrumented for logging. You'll probably also want to use logging there. Quickly, distributed tracing. This is kind of one of those jargony words you hear thrown around. It's really not that special. It's just the idea that you can, from one service to another, pass information or pass really who called who information. It really is just a header with some, like a made up ID. The calling service makes up the ID. The receiving service receives that ID, sets, and then every time it emits telemetry, it says, oh, this is the ID that called me. It doesn't have any more information, but then when you put it all together in an observability platform, it can like tie those IDs together. So let's talk about OpenTelemetry. OpenTelemetry is the shiny new thing. It's the future. It's what you're probably going to be using for observability. It brings together a lot of existing standards. They're called like Open Census and some other stuff. Doesn't really matter, but it has spans, tracing, metrics, and logging. And what it really is it's a spec so that everyone can agree on what to call these things, on the structure of the data, that sort of thing. And then practically it's SDKs and implementations for many different languages, web frameworks, database drivers, all these sorts of things. It's a CNCF project, it's open source, it's maintained by a lot of big companies, including telemetry like observability platforms, Datadog, all these kinds of people contribute to it. It's a really cool project. But OpenTelemetry is not simple. You still have to choose a lot of things. You have we traded the logging formatter, street handler, all that stuff. We traded it for text map propagator, processor, an exporter. Do I use a gRPC exporter, HTTP, a tracer, which you have to generate with a tracer provider? There's the API PyPy package. There's the SDK PyPy package. And then you try the docs, and because it's a relatively new project that's in flux and it's complex, the docs didn't work. You maybe found some older ones, or they're outdated, who knows. This is what it looks like to set up OpenTelemetry. Like I said, you have to choose a processor. In this case, I'm choosing the console process. I'm choosing the batch span processor, which does batching and exports things in a background thread, along with the console exporter, which again is kind of like just printing it to the console. I'm going to make a tracer provider. I'm going to set that as the global tracer provider with a trace module. Then I'm going to get my tracer from the trace module, giving it a name. Again, this could be under name, but you can also give it a meaningful name. And then finally, I can start emitting spans. I'll also point out that you can attach structured data to these spans, because unlike logs, they don't just end up as strings. They get sent structured over the wire. So you can, add a dictionary of data, a list of stuff, whatever you want to add there. But now let's talk a little bit of costs, right? You started adding all these traces, you did all this magic at instrumentation, but now you started sending it somewhere and you got a bill for $1 million. That's not good. So my quick recommendations on costs, just so you don't get blown out of the water when you first start trying this stuff. Metrics are great. Sampling is important. Sampling means you only keep 1% of the data. If you have really high volume, that's perfectly fine. You'll still get meaningful information out of that. There's two types of sampling. There's head sampling, which means you decide what data you throw away before you start emitting it. That's just using like a random number. And tail sampling, which can be fancier. You can say like, I only want to keep exceptions, or I want to keep this or that, but also is more complicated to set up. Then you have retention. This would be a feature that wherever you're sending the data provides. So you can say, I only want to keep data for 2 weeks or for 5 days. That's enough to debug incidents. And after that, throw it away to reduce costs. And then I also say, think about sending data out of band. This is something you'll have to do. Like if you want to like save information about a pandas data frame or something, maybe save the data to S3 and just include the key in your logs. Don't just like try and dump that to a dict and then put it in your logs. You could, but you're going to pay quite a bit more for that. So what does this all end up looking like in the end? Well, the thing about OpenTelemetry is you still have to send the data somewhere, and it's an open source, free project developed by a lot of people. But you're probably going to end up sending that data to an observability platform. That could be there's a ton of them. That could be Datadog, Relic. Like I forget which ones support OpenTelemetry now and which ones don't, but if they don't, they will. So pick your observability platform. You can send them OpenTelemetry data. And the idea is that you're going to end up getting something like this, where you can search through your data, you can see how long things take, you can debug errors, like all that kind of stuff. Different platforms offer different things. And this is where I'll say I work for Pydantic. We're both an open source project, but we're also building an observability platform that's called Logfire. This is a screenshot of Logfire. And we're presenting more on what Logfire is in particular and the features of our observability platform that we think will really, really resonate with all of you at 12:35 in lasagna. Thank you.
Thank you very much. I will see there are some questions on Slido, but
Can we do one or?
Sorry?
Can we do one or two or?
Yeah, sure. We have plenty of time.
Okay.
But yeah, no one has used it. There are
no
questions
questions
in the room.
Okay.
Okay. No, wait. Thank you.
Is it faster or is it slower than logging? Do you have a computational overhead?
I'd say I expect more overhead from using like OpenTelemetry than from using logging. I think there's just more going on. It's not like, I wouldn't say it's like inherently greater. I just, having looked at the source code, I think there's more source code.
We have one from the Nikon. Does adding OpenTelemetry add latency or use extra resource for logging purposes?
Yeah, it's a great question. So most of the time when you set it up, you'd use like that batch span processor I showed. And what that means is there's like a background thread running that's creating batches of your data. So it'll only send out data once it's accumulated a certain amount or every 5 seconds or something like that. So when you actually emit a span, there's not going to be much overhead associated with that, but there will be HTTP requests going on in the background to send the data. Now, that doesn't mean there's no overhead. So if you're like trying to sort a list and you give it, like the key function is a function that's also emitting spans, and you pass it a 1,000,000 element list, that's going to get considerably slower. But if you're making a database request that takes 50 milliseconds or 10 milliseconds, adding less than a millisecond of latency on the compute that's taken to create this span object and pass it to the background thread and that kind of stuff, you're probably never going to notice that.
Okay. What's a good starting point to get an entry to OpenTelemetry? Which platform would you use to have a low complexity entry?
Logfire.
Based. And then we have, is it worth to set OpenTelemetry for endpoints that are used infrequently and do expensive computation?
Yeah, I mean, I think, well, it's really up to you in your application what's important or what's not. It's like, is it important if that endpoint, fails or gets slower? Do you really care? I mean, sampling is a really important thing. Unfortunately, there's no good story right now for sampling like an endpoint differently than another. Like, say, hey, I want 100% of the data from this endpoint, 50% of the data from this one, and 0.1% of the data from this one. There's no good story for that in OpenTelemetry. I think there will be in the next couple of years, but right now you kind of have to choose like a number for your entire application.
How much overhead is caused by using the auto instrumentation with OTel compared to manual instrumentation in your experience?
There's really no overhead. I mean, the way the auto instrumentation goes is it just adds hooks to the things it's instrumenting. Sometimes, unfortunately, via monkey patching, I think that will improve in the future. But really, it's just essentially editing the code and adding the spans that you would be adding anyways. So there's no more overhead to that versus manual instrumentation. Now, if you go and you auto-instrument everything in your code base, now you're just emitting more spans in general. But that's not more overhead than if you went and edited those packages or whatever to add those spans.
I will fix it later. Sorry. Curious! Exclamation mark. So, does Span use Context Manager internally?
I mean, most implementations of tracing use context managers as to in Python at least, to represent, what a span is. In other languages, it might create an object that then gets dropped, and when it gets dropped, that's when it ends. But in Python, we use context managers, and it's really just like the right primitive to capture something that, encapsulates a unit of work, has a, starts and ends, and has a duration. I mean, yeah, it uses context it probably opens other context managers internally. I'm not sure if that was a question.
Yeah, I mean, it's not really my job, but I think it was cool. Any advice on how to structure your traces so to simplify debugging when something goes wrong?
I mean, I think, you know, it's really, there's no secret. It's just like with logging, you need to like think a little bit up front about where you need, you know, to put traces. You know, where is there likely to be errors? Where is there likely to be slowness? What parts of your code are interesting and important? So, I mean, like an obvious one is like a database query, right? Like you have an endpoint. You want to know how long it took to process the entire request, and you want to know how long it took to do the database query. That way, you know, when it's slow, you know which one it is. If you see the database query slow, you're like, ah, maybe I need to add an index. If you see the whole thing is slow, you're like, huh, am I like running expensive sync function in my async, you know, endpoint or something like that? So really, it's just up to you to know what information to include and where to put the telemetry.
I think this one is worth it to check it together because is there a strategy for OpenTelemetry, I think, if you're on premise with no cloud access?
Yeah, I mean, so the nice thing about OpenTelemetry is it's an open standard, and there's actually several open source projects that you can self-host. Logfire, you know, we can talk about it at the other presentation, is not an open source project. Like part of it is the part that you'd run, but like we don't give it to you for free is the point. We're trying to make a commercial company. We want to make money and we want to support Pydantic's development. But there are other projects out there that are completely free, open source, observability, you know, platforms in a repo or whatever we want to call them that you can, you know, clone, edit, or just host yourself. And you can send your OpenTelemetry data there. If you're there's also other companies that already offer on-premise solutions. We plan on doing this at some point. We don't currently, where you can host their observability platform with like a license or something.
Okay. You still have a question? Okay, thank you very much. Okay, we have 2 minutes left, so if you want to, okay.
Completely new question here. So if I want to start from scratch on the topic, I can start even if it's not free with Logfire. So it takes my hand from the beginning to having something completely working without having to learn million pieces to combine together. Like there is some glue between all the pieces, or it's just a part of something that solves part of the problem, but there are another 1,000 million tools to learn and so on.
Yeah, I mean, that's the idea of Logfire, right? It's that, you know, there's OpenTelemetry, like we saw, you can set it up. It's just a little bit complicated. You have to learn all these primitives. We just choose, you know, what we think are sane defaults. So you don't have to configure as many things. You can still go and configure them once, you know, maybe you're like more advanced and you're doing more stuff and you need more customization. They just say you can still do that. But we're trying to make it so it's just simpler to get started, and you don't have to learn what the tracer provider is and all that kind of stuff. You can just start emitting some stuff.
Okay, last question, I think. We have just 1 minute. Is logging going to die soon? What's your opinion?
Yes and no. I mean, I don't think this. I mean, the standard library logging module in Python is going to be there, you know, forever. They're not going to remove it. So I don't think logging is going to die in that sense. I think, you know, when people set up a new, a new application, they're going to be using Logfire or, you know, some other the OpenTelemetry SDK directly. I think a lot less people are going to be relying on standard library logging and, you know, parsing string logs as their primary source of observability. I do also think there's a chance that, you know, at some point Python adds some sort of tracing in the language itself, and then new libraries won't be using standard library logging. But I mean, logging's been around for so long and it's so ubiquitous that it's going to stay around for a while.
Okay, the time at our disposal is finished. So thank you very much for attending, and thank you for your talk.